In the first polar video, we talked about how to graph a point that's in polar coordinates and how to convert points back and forth from polar to rectangular form. Remember, polar coordinates work on a radius and an angle. So it's a rotation angle moving a distance r from the center or from the pole. Today we're going to focus on how to convert equations from rectangular form to polar or polar to rectangular. Be sure to set up your paper in Cornell Note format and write down your goals for today. Okay, also here are some formulas that we talked about in video 1 that we're going to need to use today. So I'd like you to get those written down again. Formulas for x and y, and then for theta and for r. Okay, so we're going to start by converting equations from rectangular form to polar form, which means our equation will have an x and y, and we need to get it into a form that only uses r and theta. So we're going to need to use our formulas, and we're going to substitute for any x's and y's. So in this equation, x equals 3, which we know would be a vertical line crossing the x-axis at 3. We need to substitute the formula for x. And according to our formulas, x is equal to r cosine theta. So we're going to substitute that in and get rid of the x. So r cosine theta equals 3. Now, when we're in polar form, we want the r by itself. Just like when we are in rectangular form, we usually have it in y equals form. This time we want r equals. So to get this in r equals form, I need to divide both sides by cosine. If it's r times cosine, the opposite would be to divide. So now it looks like r equals 3 divided by cosine theta. But we don't like to leave trig functions in the denominator of a fraction, especially single trig functions. So we want to think about the reciprocal. What is the reciprocal function for cosine? And the reciprocal for cosine is secant. So 3 divided by cosine theta can be written as r equals 3 secant theta. And this is our equation in polar form. So if we graph that on a polar grid, it would look the same as the graph of x equals 3 on a rectangular grid, which again would be a vertical line crossing the x-axis at 3. Both of those would graph to look the same, whether we're on a rectangular grid or polar grid. Let's try one more. And remember, we want to get rid of the x and the y. So we need something that we can substitute. And if you look at your formula page, x squared plus y squared is part of the formula for r. Remember, r is equal to the square root of x squared plus y squared. Okay, so if I want to get rid of the square root, I can square both sides. So r squared is actually equal to x squared plus y squared. And that's what I'm going to substitute in. So x squared plus y squared becomes r squared. So if r squared equals 16, again, we want the r by itself. So now we're going to square root, and we're going to end up with r equals 4. And that is our equation in polar form. Now, these two equations would graph the same if we were graphing them, depending on the grid. Okay, x squared plus y squared equals 16. If you have two squared terms and they both have the same coefficient, that is a circle. So this actually graphs to be a circle with our center at the origin and a radius of 4. So r equals 4 would just be a radius of 4. So this is the graph of a circle. Okay. Now, what happens if you have to go from rectangular form into polar form, or from polar into rectangular? Okay, so this time we want our answer to have x and y and no r's and thetas. So anything that has an r and a theta, we're going to have to replace, and we're going to have to get this so that it's only x and y in the answer. So again, we're going to look for formulas that we can substitute. Okay, so r cosine theta hopefully is a formula that you recognize, and we know that r cosine theta is equal to x. So I would replace the r cosine theta with x, and I get the equation x equals 3. So this is just the reverse of the first example we did when we were converting from rectangular to polar. Okay, we only want x's and y's when we're going to rectangular form. And again, this would be a line that's vertical crossing the x-axis at 3. Okay, a new equation. We've got r equals 4 sine theta. Now I don't have a formula that I can put in that just replaces sine or the 4 sine theta or something like that. It doesn't look exactly like one of our formulas. But we do know from the beginning of trig that the formula for sine of theta is y over r. So I'm going to replace with y over r for sine of theta. Okay. Now, if this is divided by r, to get the r to the other side, we can multiply both sides times r to get this to cancel. And so now we've got r squared equals 4y. Remember, our goal here is to get rid of any r's and any thetas. So we've gotten rid of the theta, but we haven't gotten rid of the r. But now we have an r squared, and we do have a formula for r squared that we just looked at, and r squared would be x squared plus y squared. Okay, so now I've got an equation. It is in rectangular form, but we do want to think about what is this the equation of. Okay, and again, if we have got a x squared and a y squared with the same coefficient, that means this is the equation of a circle. And that's not the standard form, how we write the equation of a circle. So we do want to do a little rearranging on this. Okay, so I'm going to keep the x squared, y squared. I need the 4y to this side, and I'm going to have to do some completing the square. So think back to Algebra 2. Okay, and we're going to complete the square, especially for the y's. The x, since I don't have a single x term, it's just x squared, I can leave that alone. Okay, so to complete the square and write this as a perfect square trinomial, I'm going to take the y term. I need half of that coefficient squared. So half of 4 is 2. 2 squared is again 4, so I'm going to add 4. But I can't just add 4 on the left side of the equation without adding 4 on the right side. Okay, so I've still got my x squared. Now I'm going to factor y squared minus 4y plus 4, and it should come down to a binomial squared. And to get the y squared, it's y times y. To get the 4 would be 2 times 2. And it's going to have to be a minus to get a minus 4y in the middle. So we've got x squared plus y minus 2 quantity squared equals 4. And again, that is the equation of a circle with a center at 0, 2, and a radius of 2. Because if it's equal to 4, that's the radius squared. So if we had to graph this, okay, our center is at 0, 2, and then the radius 2, which means I'm going to count up, down, left, and right 2 to get a rough sketch of our circle. Okay. Okay, again, remember when you're going into rectangular form, you need only x's and y's. When you're going to polar form, you want only r's and thetas. Okay, we're going to do one more example because it's a little bit different. This time we just have theta equals pi over 3. And I need to get this into rectangular form, which means I need x's and y's and not the theta. Okay, so on this one, what we're going to have to do, since we just have a theta and there's no formula for theta, but we do have a formula for tangent of theta. So I need to write this as tangent of theta. But I can't just say tangent of theta on the left and then keep the right side the same. So I need to say tangent of pi over 3 on the right. Okay, so I'm going to tangent of theta equals tangent of pi over 3 means that theta does equal pi over 3 for those to be the same. Okay, now we do have a formula for tangent of theta. Formula for tangent is y over x. And on the right side, tangent of pi over 3, we can use our trig formulas and we can find the value of tangent of pi over 3. So since it's in the first quadrant, if we're using the hand trick, pi over 3 is your pointer finger. Tangent is y over x. Okay, so our y value would be square root of 3. Our x is square root of 1. So we would end up with square root of 3 over square root of 1, which is 1, or just square root of 3. And since we're in quadrant 1, it's a positive value. So now my equation, it has only x's and y's, but I want to write this in y equals form. So if it's y divided by x, the opposite of division would be to multiply. So if I multiply x to both sides, I will just get y equals the square root of 3 times x. Even though it has a square root, it's still in linear form, y equals mx plus b form. So this is just a line with the slope of square root of 3, or approximately 1.7, and it goes through the origin. The y-intercept is 0. Okay, so if I were going to graph this real quickly, okay, I'm going through the origin, and then I'm going up 1.7 over 1. So here's a rough sketch of what this line would look like. In polar form, if I graphed theta equals pi over 3, then that's the same thing that I would get on a polar grid. Okay, so just remember your formulas, and when you're going to polar form, you can only have r's and thetas in the equation. If you're going to rectangular form, you can only have x's and y's in your equation.